Some of the deadliest outbreaks in history began with diseases that jumped from animals to us. It's called a host jump, or a spillover. More than 60% of all human infectious diseases originated this way. Not all of them are serious. Even the common cold is thought to come from animals. Scientists have been tracking outbreaks for decades, both from diseases we know and new ones still emerging.
The number of outbreaks that we're seeing that are happening globally continue to increase.
So, why is this happening, and how do diseases jump between hosts? Infections that spread from animals to humans are called zoonotic diseases. They're caused by pathogens such as viruses, bacteria, or parasites. It's viruses that have driven many of the recent outbreaks, including coronaviruses, Ebola, and hantaviruses.
Bacteria can be dangerous, but they tend not to spread quite as rapidly and as wildly as viruses do. Viral pathogens have been particularly associated with pandemics. There was the massive pandemic of influenza in 1918. It killed an estimated 20 to 50 million people.
A virus needs a host to survive and spread. To infect a human, it must first enter the body and attach to a cell. Viruses have proteins on their surface that allow them to invade this cell. It's a bit like a key, opening a lock. But for a virus that usually infects animals, finding the right combination to infect humans often requires several mutations. Most viruses fail to find the right key, but once one has, the virus can hijack the cell mechanisms to make copies of itself, releasing hundreds or even thousands of viral particles that go on to infect more cells. For the virus to even have an entry point into the human body, there needs to be close or direct contact with an infected host.
So these infections occur when healthy individuals come into direct contact with fluids or meat or even fecal materials from infected animals.
Every time humans and animals interact, there's a small chance a zoonotic disease could jump the species divide.
In many of those instances, we don't really notice because they come and die out. But in some cases, some of these infectious agents, they cause a lot of damage.
One of the main reasons for the increase in outbreaks is that people and animals are living much closer together than ever before.
You've got urbanization, you have deforestation, and humans encroaching into areas that have been previously pristine.
Some of the biggest spreaders of diseases to humans are rodents and bats, and they thrive in urban environments. And we don't just have more animals in our cities, there are more people too. 45% of the global population now live in cities. That's more than double what it was in 1950. Changes to the climate and environment can also alter animals' habitats and behavior.
But we see then changes in where they're coming for food or for water. We see changes in human land use. And again, nothing's happening in a vacuum. All of this is pushing animals and humans closer together.
On top of this, in some places, conflicts and a worsening cost of living crisis can mean food has become harder to find.
People may be forced to do additional things like going for bush meat, what we call wild meat. And so those are now what we could consider to be the pathway towards direct contact, because they actually hunt, slaughter, and process that meat from the forest. And so in such a case, you could have a few people from those communities getting infected.
And what we all eat could be part of the problem too. Global demand for meat is surging. Farming for meat production has increased 5-fold since the 1960s. It reached around 364 million tons in 2023. Livestock farming at such a huge scale significantly increases the number of potential animals in our food chain that could host an infectious disease. This multiplies the chances of an outbreak. Against this backdrop of a growing threat from zoonotic outbreaks, international efforts on vaccines continue.
In the last 20 years, several of these viruses that are high consequence pathogens have become vaccine preventable diseases. As time goes on, we will see more opportunities for these to be held at bay with vaccines. There is still a lot of work to be done.
Part of that work is aimed at planning for what's called Disease X. That's the name given to a virus that humans haven't yet encountered and could cause a future pandemic. Scientists predict it could come from animals.
So part of the process of preparing for that is to develop vaccines that we think we can easily just slot in the genetic code of a new virus as soon as that's discovered. So rapid vaccine development is one of the main responses we can make to Disease X.
And resilient health infrastructure is also crucial in this.
Well, you can't stop diseases from spilling over from animals to humans. What you can do is get in front of them faster and to be able to have the infrastructure and logistics and trained professionals. So you're not going to stop diseases from spreading, but you can stop outbreaks from becoming epidemics and potentially pandemics.